Hello, and welcome back to Google Cloud Solutions on Air. My name is Yanni, and I run the Solutions Architecture team for Google Cloud in Southeast Asia and India. Today, I'll be going through a hands-on lab exercise to showcase how you can manage Kubernetes clusters on premises and in the cloud easily through NFOS. I'll take you through how two of the key components, GKE Hub and GKE Connect, work, and then introduce you to the lab environment. After that, I'll go through the lab step by step so you can follow along and try it out yourself. This lab is performed in a Quick Labs environment and requires a special Quick Labs access code. This code was emailed to you earlier and can also be found in the FAQ tab. If you have a question at any time, just ask in the Q&A panel below this video. Our experts are standing by. You can also check out the FAQ tab for general tips on viewing today's session. And please feel free to join the conversation using the hashtag Google Cloud Solutions, all as one word. Before we get into the lab, I want to take a few moments just to recap the basic idea of NFOS. So NFOS comprises an integrated set of services or a platform which has been developed to ensure that the entire IT organization, that's operators, software developers, and the security team, can accomplish their duties in a unified hybrid environment. These NFOS services cater to cloud migration, application modernization, hybrid, and multi-cloud management. NFOS is a 100% software-based solution, so there is no hardware installation required. So let's review this conceptual diagram here. And starting from the bottom middle section, we have container management, which is done via NFOS GKE. GKE is Google's Kubernetes engine, which is a reliable and efficient way to deploy and run containers across clusters, across environments. And this is what today's lab will be focusing on. On top of this sits the service management layer. This is a managed Istio-based service mesh offering, which can be used to connect, manage, and secure both virtual machines and containers. On top of this, we have the application development layer. This comprises not just your own in-house developed applications, but also a wide selection of production-ready development stacks, services, and solutions from Google and partners, which you can find and deploy from GCP Marketplace. This layer also includes Cloud Run for NFOS, which lets you run serverless applications hosted on-premises or in the cloud. On the left side of the screen, you can see policy management. This offers a central place to manage configuration and security policies across your fleet. The component used to do this is called NFOS Config Management, and the lab after this one goes into more detail on how this works, again, in a hands-on experiment way. On the right side, we have operation management. This is an integrated logging and monitoring service for, you name it, containers, services, applications. This all has been built in mind that assuming you're going to be using a microservices architecture, but of course also expands to traditional applications as well. The third and final lab today shows you how this works, including some of the topology graph features of NFOS Service Mesh. So that's the conceptual view of NFOS. Let's take a look at the actual implementation of what kind of components actually create this platform. So today's lab is going to be focusing on Hub and Connect, which, as you can see, are sitting right in the middle of the diagram in the control plane, which underpins all of NFOS. So these are really very core central components. As you can guess from a name, Hub and Connect are all about the centralized management of hybrid infrastructure and workloads. And the key feature here really is that they automatically register your new Kubernetes clusters, both GKE on-prem and cloud GCP clusters, as soon as they're created. And you also have the option to manually add clusters created outside GKE into this. So what this means in practice, if you look at the diagram on the bottom left, you can see we have an NFOS cloud stack. This consists of GKE, that's Kubernetes engine running on GCP. On top of this, we have, again, the NFOS service mesh, ASM. And then we have the configuration agent, which is used to manage the configuration. And on the right side, you can see a very similar looking stack only this is running on premises. So it's using GKE on-prem as the bottom layer, and on top of that, we have Anthos Service Mesh and the config agent. So once your cluster is hooked up into Hub, you can interact with your on-premises workloads from the Cloud Console in exactly the same way as you interact with your workloads in the cloud running GKE. Let's take a closer look at how the connection out from your on-premises environment into GCP is made. So the key component here is a tool called GKE Connect Agent. This is a Kubernetes deployment, which is installed in your on-premises Kubernetes cluster. Now, the key feature here is that the connection from the Connect agent into the cloud is purely outbound. So the connection is initiated on the on-premises side, and there's no inbound connections ever from GCP into your cluster. So this means that there is no public IP required for your cluster. You don't need to open up your cluster to anybody coming from the outside. The connection from on-premises to GCP is authenticated and encrypted with TLS. And because there is no inbound IP required, it can easily traverse nets and firewalls. Once the connection has been created, VPC service controls are used to ensure that GCP appears as an extension of your own private cloud. In the other direction, as users interact with your on-premises cluster from the Cloud Console, all these interactions are logged, so they can be viewed and reviewed easily using the Kubernetes audit logs on your on-premises side. The end result of this is that you get a single pane of glass across both cloud and on-premises. This allows you to orchestrate and manage your on-prem containers in exactly the same way as you would manage containers running in GKE in the cloud. The end result is a consistent operating model with access to GCP services across hybrid environments. It's a single pane of glass for multiple GKE clusters, no matter where they're located. With the theory out of the way, let's take a look at the structure of today's lab. So in this little diagram here, on the left, you can see we have a GKE cluster, which is running in the cloud. And on the right side, we have a GKE on-premises cluster, which is running on-premises. So what we'll do in the lab today is you will tie them together with Connect and Hub, and then you can manage the workloads running in both clusters easily from the Cloud Console. Now, one disclaimer I need to point out here is that in a real-life environment, the on-premises environment would, of course, be running on-premises. But in this case, for just ease of testing, basically, we actually are simulating the on-premises environment using some virtual machines running in the compute engine. From the user's point of view, interacting with the UI and the command line tools, this makes very little difference. But if you would like to have a more realistic simulation of this running on VMware, or potentially even deploy an Anthos trial in your actual data center, please reach out to your friendly Google sales rep. So this is what you will accomplish in today's lab. You will access your remote cluster. You will register this remote cluster with Hub using GKE Connect. You will add some metadata to the remote cluster. You will review the clusters in Hub across multiple locations, that's in cloud and on premises. And last but not least, you will review the Kubernetes workloads, which are running in Hub across all clusters. Again, that's on premises and in the cloud. So I'm going to start my own lab walkthrough now. You can also kick off the lab now, or just watch, kick back, and give it a shot later on. You can find the Quick Labs access code needed to access the lab, and all other details of how to load up the labs on your side in the email we sent you earlier, or via the FAQ tab on your screen. So after opening the lab link in an incognito window in your browser and logging into Quick Labs, you should now see this lab page, managing hybrid clusters using Kubernetes engine. We've already gone through the Anthos overview and also the architecture and objectives of the lab. So I'll skip these parts and go straight into task 0, which is the lab setup. So you'll notice that you have 1 hour and 45 minutes allocated for this lab. In practice, around 45 minutes is usually sufficient. Do note, though, that there is no pause feature available. So you can stop the lab and come back to it, but if you do so, you'll need to start again from the beginning. So once you're ready, just click on the Start Lab, the big green button here on the top left. And this will then start provisioning the resources needed for the lab. Now, this is spinning up a couple of new Kubernetes clusters and a bunch of virtual machines, so this can take about 10 minutes to complete. So if you're trying this out yourself, this probably would be a pretty good opportunity to take a break and maybe go get a cup of coffee. However, in this video, we will use the magic of editing to speed up time, and I will see you once the provisioning is complete. Okay, as you can see, the provisioning is now complete, and we can keep going with the lab. So what we're going to do now is you want to click on Open New Console and open this in a new tab. Copy the username using the handy clipboard icon here and use that to sign in. So it's important to use the assigned credentials here. Do not use your regular Google account because that will not have access to the resources that we need. Copy the password as well. And now we should be able to log in and accept the terms of service. We can skip the account protection because this is a temporary account anyway. And in a few moments, the Google Cloud Console will appear. And there's still one more dialog to click through. It should show up momentarily. There we go. So just choose your country and agree to the terms of service. Okay, we are now ready to go. Let's increase the font size a bit. So we're now ready to go on to the next section, which is to activate the Google Cloud Shell. So the Cloud Shell is a virtual machine which is pre-provisioned and can be used to easily connect to your GCP resources. It's a completely free resource, and you can open it up by clicking on the Cloud Shell button on the top right of the toolbar. That's over here in the top right corner. So just click on that. And then choose Continue. So this is now creating a new virtual machine for you. So while we do that, just go over here to the far right corner and click on the Open in a New Window button over here. So this way, it's a little easier to see what's happening. And here as well, let's increase the font size just a bit. Okay, we are now inside our Cloud Shell. So let's do a couple of brief sanity checks. So when you're connected, you should already be authenticated, and you already should be connected to the correct project, which you can see here on the left side. Let's just double check that we're using the right account. So from this point on, most commands actually will be entered into gcloud. And instead of manually copying and pasting, you can just click on the handy clipboard link here on the right side of each command. Just click on that, switch over into our Cloud Shell tab, and this should validate that we are currently logged in as the student account, which is what we wanted. And now we can also double check that we're using the correct project. So again, just copy this. And as you can see, we are using the Quick Labs project as we wanted. So looks like we're good to go. We've now come to our first task, which is to understand and install multi-cluster Kubernetes environment. So what we're going to do is we're going to review the clusters we have in the lab, enable the APIs that we need for the rest of it, download a couple of files from GitHub, and then run a bootstrap script, which will install the tools that we need to work with these clusters. So a quick refresher of the architecture of the lab. So here on the left side, you have the cluster which is running inside Kubernetes engine in GCP. And this one is called Central. And here on the right side, you have our simulated on-premises cluster, which is remote, and that's why it's called remote. So in real life, you probably would be running this on premises, but again here, to avoid using VMware, we're actually going to run this on Google Compute Engine. So we need to enable a couple of APIs. So let's just copy this and paste this over into Cloud Shell. This again can take a couple of moments to complete. So basically what we're doing is we're allowing Cloud Shell access into various GK APIs, the GK Connect API, the GK Hub API, and the Anfos APIs. And there we go, the operation is now complete. And if you wish, you can confirm that they're enabled by navigating to the menu, but we'll skip this one for now. The next step is to clone the lab repo and to cd into this directory. So again, we copy this git command. So you notice the git has already been installed for you on Cloud Shell for your convenience. So just paste that. That should only take a couple of seconds. There we go. And now we can just cd into the directory. And now the last step right here is to run the connect script. So this is going to install the kubectx or kube context tool, which we use to switch between clusters. It's going to install kops, which is the command line tool used to manage the simulated on-premises cluster. And it will update some firewalls, so rules, so that the Cloud Shell can access the clusters. So again, copy the command and paste it into Cloud Shell. And now we're installing the tools. So you'll note the warning here that the Cloud Shell environment is ephemeral, so any tools that you install on this virtual machine may be wiped out if you reconnect to Cloud Shell later on. But for the purposes of this lab, when it's a single session, that's not going to be an issue. And you also do have a persistent home directory where you can store anything that you would like to keep for a longer time. So we've now installed the kubectx, we've installed Istio, we're now installing kops, and now we're starting to generate the kubeconfig entries that will be used to connect to the clusters. So here we have the context for the central cluster running on GCP. And now it's going to start provisioning the simulator configuration for the remote cluster. That's also done. And up next, it's going to update the firewall rules that we need to access the remote cluster from Cloud Shell. One more firewall rule to go. And we're good. Okay, so we have now set up the cluster, and let's see what we have available to us now. So next task is to use GK Hub to authenticate and register a remote Kubernetes cluster using GK Connect. So as a reminder, GK Hub is the centralized dashboard that lets you view and manage all your Kubernetes clusters from one central location. And these clusters can be located in GCP on different clouds or on premises. And the way these clusters get connected to GK Hub is the GK Connect agent. And the agent's job is to reach out to GK Hub APIs, listen for commands, and provide updates. So To operate, GKE Hub needs to have the outbound connection we mentioned earlier, so the pods in your cluster can reach googleaps.com and GKE connect to googleaps.com, either directly or through a proxy. So what we're going to do now is we're going to review the existing clusters we have. We're going to make sure that we can access the remote cluster using kubectl. We're going to create a service account with a private key, install the agent, create a Kubernetes service account, and then use GKE Hub to register and connect to the cluster. It sounds like quite a bit, but actually it's fairly straightforward. So now let's navigate over into Cloud Console and see what kind of clusters we can see. So go over here into the menu on the left, choose Kubernetes Engine, and from here just navigate over to Clusters. We actually also can close the Cloud Shell here at this point because it's open in a separate window. Again, we're opening this for the first time. It can take a few seconds to load, but here we go. So as you would expect, we can see the central cluster because this is running on GKE and GCP itself. But at this point, we cannot yet see the remote cluster because it has not been registered into the system. So this is what we expect. Now let's make sure we actually can access the remote control. So this requires two steps. First, we need to switch the context to the remote cluster. So we enter that command here, kubectx remote. The context has been switched, so it's now using the correct kubeconfig. And the next step is to verify that the cluster is actually running. So kubectl get nodes. And here we go. You can see that we have one master and two nodes, as you would expect, which are all ready, and they've been around for about 10 minutes. Okay, so this has shown to us that the remote cluster is up and running, so now we can start connecting to it. So the next step is to use a Google Cloud Service account to create a private key file. So the lab has already provisioned a service account with the name project ID and project ID imgserviceaccount.com for you. So what we're going to do now is we're actually going to assign the IAM role gkehub.connect to the service account. As far as two steps, so first we create a couple of environment variables. I can paste these into Cloud Shell. And then we actually will add this role into service account with the add IAM policy binding command. So run that now. This may take a few seconds, and there we go. It also has dumped out the full configuration of the service account here for us. So that's all good. And the final step is to generate and download a private key, which we're going to use in a subsequent step. So we copy that out, run this here. And as you can see, we have created a key, which has been output as JSON into this directory here under name Anthos Connect Credits.json. So the next step now is going to be to install the Connect agent on the remote cluster. So again, let's start off by just exporting the cluster name into an environment variable. So we copy that, paste it over here. And now what we're going to do next is we're actually going to register the remote cluster, again using this context and using the service account key file we just created in this project. So run this command. And this actually does quite a bit of stuff under the hood, which it will shortly tell us a bit more about. So initially we create the membership. We generate the Connect agent manifest, and we deploy the Connect agent on the cluster in the namespace GK connect. So this way there's no conflicts with any other pods you may have running. And once the connect agent is deployed, that's it. We have now registered the cluster with the hub. So let's now confirm if that actually worked. So all we can do is let's take a look again at the Kubernetes clusters page in the Cloud Console. So, and again, this is the old view still. Let's refresh that manually. Click on refresh up here. And now if things go well, actually you should see 2 clusters, and we do. However, so remote has shown up here, as expected, but you can see it's still showing up in gray because we have not logged into the cluster yet. And because we haven't logged in, we don't have any access into details of the cluster. All we know is that it exists. So let's do the login next. So to finish off the registration, we need to authenticate and log in into this cluster. And there are multiple ways to do this. So the easiest option is to use basic authentication, which means just a username and a password. However, in most modern Kubernetes clusters, which have RBAC, that's role-based access control enabled, this method of authentication is not allowed because it's a bit insecure. The second option is to use OpenID Connect, but today we actually will use token-based authentication. So we actually will use a Kubernetes service account, which has the proper RBAC rule set to authenticate using its secret as a token. So let's just double check that we actually are still in the correct context. So we do view context remote. Let's create a new Kubernetes service account called remote admin SA that we'll use to log in. So again, copy the command and paste. Now kubectl has created the service account in the remote cluster. We take this brand new service account and we assign it the cluster admin cluster role, which is basically the super user role in Kubernetes, because this will be used to actually manage the cluster. So we have created that role binding. And last but not least, let's extract the token from its secret using a bit of regular expression magic and set. So this now outputs a token for us. Now what you want to do now is you actually want to copy this carefully from the first character to the last one. And one tip at this point is you actually do not need to press Control-C at this point. Simply selecting is enough to actually get this copied into your clipboard. So if you select and you let go, you will see that little scissors icon flash on screen, which means this has been now copied into your buffer. So with the token now in our clipboard, we actually can go into GKE Hub and log into the cluster. So let's again go back into the Kubernetes cluster view where we were earlier and click on the login button. So from here, you want to choose the first method, the token method, and just paste the token that we just created. Let's try our luck logging in. Page will refresh, and as you can see, the tick has turned green. So we now actually have access into the remote cluster. And we can see the basic stats here already. So we know it's a non-GKE Kubernetes cluster, which consists of 3 nodes, has 5 CPU, and has some memory. And there also is a logout button, which can disconnect you, but let's not press that just yet. Okay, these are steps we just took. So now we are all good, and we can move on to the next task, which is to add some metadata for this remote cluster. So obviously in this lab, we only have 2 clusters, so this is not that big a deal, but in a production environment, you might easily have tens, if not hundreds of clusters running, and it's important to keep them labeled so you know which one is which. What we're going to do now is we will switch back into the Cloud Console view, and you want to choose Show Info Panel. Then you want to select the cluster you want to edit. So let's just tick this checkbox next to Remote. And now you can go over here and do add label. So you can actually choose basically any key value pair that you like. Let's go with location for the key and remote for the value. And you can save. We can now close the info panel. We don't need it anymore. And you can see that a label has been attached. This just makes it easier to tell apart which clusters are where and what functions they serve. So there we go. Your updates are now there. So let's move on to task 4, which is to review your GKE clusters, both remote and on Google Cloud with the GKE dashboard. So we're going to inspect the underlying nodes of your remote cluster. So let's once again go back into the Cloud Console, and now let's click through into the just connected cluster here. So you want to go over here into the name of the cluster, which gets highlighted, and just click on the word remote. And this will now open up the detailed view into the cluster. So here we have the basic details. So now I can tell what the master version of Kubernetes running here is, nodes, core, memory, totals, and that we are logged in as well. You can now go ahead and click on the nodes tab here on the right. And this now shows us that we have one master and 2 nodes running here. And we have details of how much CPU each node has requested, how much there's available, how much memory requested, and so on. So the next thing we can do is we actually can click through into one of the nodes to review some more details about that node. So let's do that. So just choose the first node. The name you have on your side may be different. These are randomly generated. I'll just pick the first one. And this will now go ahead and pull some information about node. So you can first of all you can see what pods are running on this. So we have the basic services like Kubernetes and also the GKE Connect agent we deployed earlier. And you also get a summary of the resources being used. So how much capacity there is, how much is available, how much has been requested, and also various useful conditions to see if there's anything which is looking a bit out of ordinary. But in this case, you can see it's all green, so there is no pressure on disk, memory, or PIDs. All in all, it's ready and it's good to go. Okay, so now we've reached task 5, which is to review the workloads that you have running in multiple locations across all your clusters. So previously, we saw how it was possible to review which pods are running on a specific node, but because one of the whole ideas of Kubernetes is that it's orchestration, you don't need to worry about micromanaging what runs where, you just let Kubernetes handle that for you. So this is what the workloads view is for. So it lets you view workloads across the entire cluster. So we're going to go back into the Cloud Console now, and you want to choose the next item down from clusters, which is workloads. So just click on workloads right here. You can click away the helpful pop-up about more solutions for your business. And right now we have a filter here by default which says is system object false. So we're only seeing the non-system deployments. And the only one we have visible right now is the GKE Connect agent we earlier deployed into the remote cluster. So let's just remove that filter so we get a bit more data to play with. So just click on the X there, and it will reload. And now, as you can see, we actually have a list of all the workloads, system and otherwise, running. And this single list here, as you can see, it covers both the remote and central clusters in a single place. So the next step is to pick a workload which runs in both clusters. So Kubernetes is an easy one because this is guaranteed to be running in most Kubernetes deployments. And as you can see, we have one copy here in central, and we have another copy here in remote. So let's click through into the central one. Just click on the name again. And you can see here that we have a whole bunch of information about this deployment. So here we have the graphs of CPU usage Again, use requested limits, the same for memory, and also disk over here. If you scroll down a bit, you get some more information about the namespaces, the labels attached. You can click through directly into the logs, which take you into the cloud logging service for the container and the audit logs. Details about the pod specifications, and you have the list of the active revisions. So obviously, being a brand new, fresh cluster, there's only one revision running. And you can see that this deployment consists of 2 pods, which are both running here. And you actually can even click through into the pods and see more information about them. So for example, which node they're running on. Let's take a look. So for example, you can see that this particular pod of the kubedns deployment is running on this node. And again, you can actually click on this node and this will take you back into the node view that we saw earlier. And of course, this even you can keep going down the rabbit hole. So you see also the containers which are contained within this pod, including even the sidecars which are used for the linkage to the Stack Harbor logging suite, now called Google Logging Monitoring. Let's climb out of the rabbit hole for now. So let's just click back here to get back into the deployment level. And I should also mention that there are some more tabs that you can access here. So we have the details tab here, which tells you a bit more information about this. And you have the revision history, which tells you what changes have been made. And also the events history, which tells you things like, for example, when this deployment was originally rolled out, it scaled up first to 1 pod and then into 2 pods. Okay, let's now go back into the workloads view. So that was the kubedns running locally on GCP. Let's click through into kubedns on the remote system, or the remote cluster cover, and you'll see this looks quite similar. So again, here we have the active revisions, we have the managed pods, we have the exposed services. And again, if you, let's say we just click through into the first managed pod, you'll get some more information about this pod, including that it's running on this particular node of the cluster. And once again, the containers running inside that pod. So let's go back out into the workloads view. And there we are. So at this point, you have now completed the lab. And once you finish the lab, you can just click on the End Lab button here. Just do be aware that once you have clicked on End Lab, there's no turning back. You'll need to restart the lab from the beginning if you want to go back to it. So let's click on that, accept the warning. And then if you are happy with this lab, and like me, think it's very smooth, you can go ahead and submit your feedback to the lab creators. And this brings us to the end of this lab. You've now seen how to use GKE Hub to authenticate and register a non-GKE Kubernetes cluster, set some metadata on this cluster, and use the GKE dashboards in the Cloud Console to review information both for the clusters themselves and the workloads running across them. Now it's your turn to try it out, so I hope you enjoy doing the lab. We appreciate any and all feedback, so please let us know your thoughts on this session. Just click the survey link in the Q&A panel below this video. If you enjoyed this session and know someone who would also benefit from watching it, please share it with your friends and colleagues. You can also follow our social channels, join the conversation, and tag us with hashtag Google Cloud Solutions on your preferred social media. Up next in the program, my colleague Prakar will be taking you through how Anthos can help you manage configurations across a hybrid cloud environment. An issue we often see is that in a hybrid cloud spanning multiple environments, it's pretty easy for configurations to drift with some security or access policies applied to some clusters, but not others. This can introduce some risk. With Anthos configuration management, you can create a common configuration and roll it out to all Kubernetes clusters so your desired state is always reflected. And you don't have to take my word for it. There's a hands-on lab, so you can try it out as well. And in the fourth and final NFOSS segment today, my colleague TTH will be taking you through the observability features of NFOSS Service Mesh. So microservices architectures present numerous benefits, but also introduce challenges like added complexity and fragmentation for different workloads. With the fully managed NFOSS Service Mesh, you can easily manage these complex environments with detailed telemetry across not just monitoring and logs, but also service-level observability and topology. And of course, there's a hands-on lab for this as well. That's all from me. Thank you for joining today, and stay tuned for more.